Yeah, greeting. Today we are going to do forces and Newton's law. It's a topic for grade 11. So let's start with forces. When we're talking about a force, we are simply talking about push or pull. When you push something or when you pull something, there is a force that is applied. So you will learn which force it is at the end of the lesson. So now you will know that we have two types of forces. Namely, we have contact forces. Number two, we have non-contact forces. But we are going to focus mostly on contact force. So, what are contact force? It's just the contact force are forces that are in touch with each other. For example, contact force, we can talk about friction. Friction, we can talk about what is a friction. Friction simply means a force that opposes a motion. It opposes a motion. For in case, if here we have a diagram or a system, a 5 kg block. This is a 5 kg block. It is going to this direction, or it is pulled to this direction. It is pulled to this direction. Friction is a force that opposes. It's a force that goes in opposite direction. It's a friction force. So we also have applied force. This is a force that push or pull in the direction where the net force is going. So if here is a 5 kg block and it is being pulled to the right, meaning this will be our applied force. We represent it by Fa. Our friction, it is represented by Fr. So this is F applied. It goes in the direction of a force. So it's applied force. We also have tension. This is just a string that acts between two objects. You can see tension in the middle. It's a force or a string that acts between two objects. If we have object A and we have object B. So a force that acts between these two objects, we call it a tension force. We also have a normal force. A normal force, which is simplified by N, capital letter N, or Fn, normal force. So this is a force that acts on a parallel to the surface. If this is in contact with the ground, so meaning the normal force will act parallel to the surface. So its opposite is gravity, Fg, which is force of gravity. Is the opposite of normal force. It always goes down, Fg. Don't forget that a force is a vector. It simply means it has both magnitude. It has both magnitude and direction. You can see here that this force 5 kg block is going to the right. So that direction to the right is a direction. If here I say 2 Newton, this force is 2 Newton. 2 Newton. Meaning the magnitude is 2 Newton. The direction is to the right. So a force is a vector quantity. It has both magnitude and it also has the direction. So you have to also understand that this N Newton is a unit or SI unit for a force. So when you present your magnitude, you have to include that is 2 Newton. Don't forget the direction. 2 Newton to the right. So you have to also know free body diagram. Free body diagram. So if you didn't understand how or if you don't understand the direction of a force, you will understand here in free body diagram. It's another way to express the direction of a force. So now, this object, which is 5 kg, if I use this example of 5 kg, 2 Newton, and the surface is rough, there is friction. So I'm going to present this block or this object by a dot in a free body diagram. This dot represents an object. So this is a 5 kg block in a free body diagram. So this force of 2 Newton is moved to the right, or it is pulled to the right. So meaning this force is F applied, which is what? It's a force that is applied on an object when you push or when you pull. So we don't have to show the magnitude because we are expressing a free body diagram. So remember, this force is acting parallel to the surface or perpendicular to the surface. We will have a normal force because it's at perpendicular to the surface. I said you can write capital letter N or you can write Fn. The opposite of normal force, because it's in contact with the ground, the opposite of normal force is gravity. Gravity is always there because it's a force that pulls everything. Everything here in the universe, it is being pulled by a gravity. It is also weight because everything in the universe has weight. Even yourself or myself, I have weight. I know my weight because when I go there and weigh, so it shows the magnitude that maybe it's 50 kilograms. So we were talking about weight. So everyone has weight. So everything that exists has gravity. So now you have to understand the surface is rough. We will have what? Friction. What is friction? It's a force that opposes a motion. This object is being pulled to the right, meaning that the friction will go in the opposite direction and will show it as Fr. So this is how you draw your free body diagram. Remember, the dot represents the object. The dot represents the object. Then the arrow represents a force. Either friction, gravity, applied or normal force. So, if you didn't understand very well, I said you will understand the expression of this. You can understand this definition by looking at the free body diagram. If you don't understand this definition, check the free body diagram. Friction. This is a force that opposes the motion. So now you will understand this term very well. This thing is opposing the motion because this thing is going to the right. So now, if you don't understand, tension is not there. That's why I didn't mention it. So normal force is a force that acts perpendicular to the surface. So now, this thing is in contact with the surface. So we'll have normal force. Gravity, I already explained that everything in the universe has a gravity. Gravity acts everywhere. So this is the friction and this is applied. Just simply means a force that is being pulled. So now, let's go to the Newton's law. We have first law. First law of Newton. First law states that an object will continue to move at a state of rest unless acted on by unbalanced force. So imagine something, there is no any, when we are talking about an unbalanced forces, we are talking about external force. So an object will continue to move in a state of rest unless acted on by an unbalanced force. Imagine something is, this chalk here is moving, but when it will continue to move, but now it finds this material. This thing, it acts as an unbalanced force because it is stopping this chalk to move, because this thing is continuing to move. If there is no this external force, this chalk will go until it finds external force. So that is the meaning of external force. We also have inertia.